me at this point in time? Any concerns? Nothing. So we're hoping that today's notes are going to cover everything that you guys need. Great. So let's finish up these parts of the notes. So the one thing that we didn't talk about here is what happens, because we were talking about last class, is that a diagonal line, the equation has x and y in it, right? So anytime we see an equation with x and y in it, then it's got to be a diagonal line. So we're going to solve for get y by itself, so that we can know what the slope and the y-intercept is, right? We talked about how going from left to right, if it's going downward, is a negative slope. If it's going upward, then it's a positive slope. But then the question becomes, what if there's no x and y in the equation? What if it's just an x in the equation? We got to solve for x. What if there's just a y in the equation? We got to solve for y. But then what kind of line are those, right? So what other type of lines could we have if it's not diagonal? What other lines could we have if it's not diagonal? Or vertical, right? So we got this line and we got this line, right? So if there's only x or y in it, then it's got to be one of those. Question is, which one? So I'm going to do this here. I'll just write down continued. So the question is, if we have, so we could have a horizontal or vertical line. So let's put a horizontal line here and a vertical line here. Okay? All right, so what's the equation of this line? So right now, you guys going, I remember this, right? In high school, someone told me that to remember the equation of this line. And I can't remember, though. I always mix them up. Is it y equals because it crosses the y-axis, or is it x equals because it's parallel with the x-axis? And what I'm about to tell you is that you don't need to remember it. You don't need to. Because the simple act of just plotting 2 points, you're going to know for sure what it is. So let's just plot 2 points, right? So let's plot 2 points here. Let's take this point right here and this point right here. Let's name these 2 points. Okay? So if you were to name these 2 points, what would those points be? What's the one on the left? -2, 3. You just want to make I am here. It's okay. It happens, right? And what's the point on the right? 4, 3, correct. Right? It's 4, 3 because I go right 4 up 3, right? I know it's different from the notes, sorry. So here's my question. If I look at that, what stayed the same? The y value as 3. So guess what? The equation of this line is y equals 3. Like I didn't have to remember a single thing, did I? I just plot 2 points and, oh, look, y equals 3. Now, if it was in reverse, if they say, hey, graph the line y equals 3, same exact idea. When it says y equals 3, it means that, hey, no matter where you are, y is always equal to 3. Which is exactly like talking about altitude in Florida, right? I'm at Marco Island, y equals 3. Naples, y equals 3. I'm at the same altitude no matter where I go, right? So when you have to graph that, just go, okay, let me create 2 points. The y is always equal to 3. Come up with some x values. Plot those 2 points, draw a line, boom, you're done. You just graphed it, y equals 3. Right? So with a vertical line, same thing. Just plot 2 points. Let's plot this point right here and plot this point right here. And let's go ahead and name these 2 points. What's the point on top? Wow, you guys are fast. And the point on the bottom? Really good. Wow, so fast. All right, so what stayed the same? The x value, and it stayed as? Awesome. So now I just have the equation x equals -2. Just got that equation. So again, if I have x and a y in the equation, I know it's going to be a diagonal line. I just need to know what the y-intercept is and what the slope is, right? However, if there's only an x, only a y, it's got to be either horizontal or vertical. Now, notice I didn't tell you, remember that y equals is a horizontal line and x equals is a vertical line. All right? I'm not trying to tell you that. I'm just trying to tell you if it's x alone or y alone, let's solve for it, plot 2 points, and we're done. We already know what it is. All right? So I'm not trying to force it on you. All right? So with that being said, let's talk about slope. So last class we talked about the slope-intercept form, y equals mx plus b. Meaning, if we get the y by itself, then we know what the slope is and what the y-intercept is, correct? Okay? But the y has to be by itself. If it is not, then I don't know. I got to get y by itself in order to find that. So when I found the slope, how did I use the slope to go from the y-intercept to the next point? How did I move? Do you guys remember? Huh? Rise over run. Is that right? Right? So we know slope as rise over run. And if the value up top of the fraction is positive, which way do we move? Up. So if it's positive, we move up. And if it's negative, move it down. And if the bottom number of the fraction is positive, which way do we move? To the right. And if it's negative, to the left. Awesome. Okay. So let's use this and figure out what the slope of these two are. Is that fair? Right? Because just because they're horizontal and vertical, it doesn't mean they don't have a slope. Well, kind of. Not have a slope. Okay? So let's take a look. So if I take this horizontal line here, let's move from point A to point B. Let's call this point A, this point B, and I got to move from one place to the other. From point A to point B, how did I rise? Did I rise any? No. So slope-wise, I rise 0. How much did I run? 2, 4, 6. Awesome. What's 0 divided by 6? If you guys don't know, just use your calculator. It's okay. I'm not going to how can you not know that, right? Yes, that is 0. So the way I look at this is like skiing. If one day student government goes, you know what, it'd be great for all of these folks to experience skiing. So they bring a snowblower in here and blow a bunch of snow in the parking lot, cleared it out, and say, here's skis, go have fun. Since in Florida it's pretty flat, right? You go out there, you're like, okay. How much fun are you having? 0 fun, right? 0 fun. You're like, oh, for me to move, I gotta like actually move with all this equipment. It's heavy, right? It's 0 fun, no fun whatsoever. That's why up north I never understood why people like cross-country skiing, because they literally have to move everything. No matter it's uphill, downhill, like they have to actually move. So it's 0 fun. Let's look at the vertical line. Let's call this A, let's call this B. Let's look at the slope. So from A to B, how much did I rise? 1, 2, 3, 4. Down 4, right? So let's say -4. Okay. How much did I run? 0. Just exactly the way I love my elevators, right? I want the elevator to go down without any movement left to right. Because if the elevator moved left to right while it's going down, you're going to freak out. True? All right, what's -4 divided by 0? It's not 0. Yes, if you plug into your calculator -4 divided by 0, the calculator is just going to flip you off. Actually, it's not going to, but it would be funny if it did, right? It's actually going to tell you divide by 0 error, undefined, right? This is actually undefined. And back to the skiing example, let's say I decide one day I'm going to take this amazing ski trip. I'm going to ski down the side of Grand Canyon. What do you think is going to happen? Ah! Wait for it. Splat. Essentially, that's what's going to happen, right? By the time anybody figures out that I'm missing, they go look for me. Guess what? My body will be undefined, right? The animal's going to take care of the meat. The bone is going to disintegrate, and I'll be gone. I'll be undefined, right? So now, the other thing I look at is these two fractions here, right? Because you're wondering how this is 0 and how this is undefined. So when I look at this, I'm that guy that goes to the party of 6 people, right? And brings 0 pizzas. Selfish dude. How many pieces of pizza is everybody going to get? 0. That's why 0 divided by 6 is 0. Let's look at this one here. Let's use that as a positive 4. Let's say I bring 4 pizzas to 0 people. Is there really a party going on? No. It's called my Saturday night. Right? So the party's undefined. It doesn't exist. I'm just making up stories. I'm just a fat slob eating 4 pizzas, right? So that's why it's undefined. Okay? Is that fair? So if I have a graph, I can always use rise over run to figure out what the slope is, right? Same thing up here. If I was to bring this graph and bring it down, right? Let's say I don't use these points here. All right? Let's say I want to find a slope. Same thing. I can just find 2 points. So I look at it. It doesn't matter if I went from A to B or B to A, I'm still going to get the same slope. right? If I did rise over run, going from A to B, how much did I rise? How much did I rise? Down, I went down 2, awesome. And how much did I run? Oh boy. 8. And it's positive, right? Because I went right. So in other words, you went down 2 and right. Actually, doesn't matter. Let's do this, though. There we go. And what is negative 2 over 8 going to simplify it down to be? Negative, no. Negative 1 over 4. Because 2 goes into both of them, right? Now, if it was 8 over negative 2, you're right. It would be negative 4. Okay? So always look at compare the numbers, right? Is that the slope that we found anyways? It was. Okay? So one way to do it with graphs is rise over run. And once we found the slope to graph it, we would also use rise over run to move how we would need to move. Great. Now, is there a formula for slope? Do you guys remember that? Ooh. So if you remember rise over run, rise is a change in y value over run, the change in x value. So if you remember rise over run, then you should remember this. Now here's the thing, guys. I want you guys to understand something. That all those numbers, those subscripts that you see there, is only for the sake of keeping things in order. That's all it's trying to do. Okay? It's saying, hey, if you use the y value of the second point first, then you got to use the x value of that second point first as well. There's no playing fair. It is what it is. Now, if you use the y value of the first point, then you got to use the x value of the first point first as well. Okay? Now, I know that's a lot to remember. So for me, I don't really actually like that. For me, I like to, give me a second here. I like to look at it as, let me give you guys an example so that you guys know what I'm talking about. So let's say, for example, that I'm given 2 points. Let's say right? Let's say I'm given these 2 points. And I got to find the slope if a line went through these 2 points. Now for me, this is what I prefer. I prefer stacking them. Now you guys are going to be wondering what I mean by stacking. Here's what I mean by stacking. It doesn't matter if you stack it this way or stacking it this way. Either way, it doesn't really matter, and I'm going to show you why. All right? I'm going to stack them. Here's why I like to stack them. Here we go. When I stack them, this is the way I look at it. So if I look, I see negative 22, negative 2, I see 6, then I see 1, then I subtract them, then I finish off. What is negative 22 minus 2? Minus the negative 2. So that is the biggest mistake that people make. they forget about the subtraction. And this is why I like to put it in different colors so that you guys can see exactly what's going on. So what's negative 2 minus the negative 2? There's a lot of numbers going on there. I think I heard negative 20. Try it on your calculator. Let's try. Negative 22 minus a negative 2. Because the minus the negative also means add the positive or add the inverse. Okay? So that's why I would have negative 20. 6 minus 1, 5. And negative 20 divided by 5, negative 4. So the question is, if I did it the other way, would I still get the same result? Only one way to find out, right? Oh boy. Yup. This is called pure laziness, guys. Hey, move, 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 move. Okay, I got negative 2, negative 20, 1, 6, oops, wrong colors, 1, 6, subtract, subtract, divide. What's negative 2 minus the negative 20? Or hence, negative 2 plus a 20. I'm sorry, that was 22, dum-dum. So what's negative 2 plus a 22? What's 1 minus 6? What's 20 divided by negative 5? Oh, look at that. I do get the same thing. Don't I? I do get the same thing. Right? I do get the same thing. So not bad. I'm okay there, right? Okay. So I can find out slope. No big deal. I'm given 2 points. I can find the slope. So here's the question. What do I need in order to write an equation of a line? So if I had to write an equation of a line, what sorts of information would I need? I know what you guys want to say. What would you say? Well, let's think about slope-intercept form. If you were to ask for 2 pieces of information to complete the slope-intercept form, what are the 2 pieces of information? So in the slope-intercept form, it would be the slope and the y-intercept, right? Because we got to keep the x and y in there, because if people don't see an x and y in there, they're going to not think it's a diagonal line, right? Now, the slope is the right answer, but you don't specifically need the y-intercept, actually. It's nice to have, but you don't really need it, okay? So the 2 pieces of information you need is you need the slope and a point. Those are only 2 pieces of information you need. That's important, because we always do think we need the y-intercept. Now, if the y-intercept is given, great, right? But we don't need it. we can get our own point, right? Like, for example, here, if you look at it, we can find a slope, right? The y-intercept isn't given, but guess what? We can still find the equation of our line. Now, with that being said, and I'll show you guys exactly how that happens. So with that being said, if it's just a slope and a point, you can use one or another equation for that to happen. Yes, you can use the slope intercept form. Remember, I called it SIF, not SIP, but SIF. And that's equal to y equals mx plus b. And there's another form called point slope form. I guess if I call that one SIF, I guess I'll call this PSF, because I don't know how else to pronounce that. That states that y minus y1 is equal to m times x minus x1. So the x and y stays put because there's no subscripts there, but x1, y1, that's actually your point. Now, you might think, oh my goodness, another formula to remember. Oh my goodness, no way. Well, here's the good news. If you look at this formula right here, guys, that formula actually came from here, right? If I put this over 1, I can cross multiply. You get m times the x's is equal to the y's times 1. That is your point slope form. Except the x2 and the y2 is just x and y. Okay? So if you just remember the slope formula, you can actually come up with the point slope form. Okay? So how would I go about doing that then? Great question. Let's bring this down. So let's say that they're asking you to okay? Most likely it's going to say, I was having a hard time figuring out what to write there. So it might usually say, like, write an equation of a line that goes through these 2 points. So what was the 2 things we need to know to write an equation of a line again? A slope and a point, right? So we go, oh, it needs a slope and a point. Great. Let's find slope. 2 points, we can find slope. Yes? True? Awesome. So we just need a point. Do we have enough points to spare? How many points do we have here? Don't we have 2 points? Does it matter which point I use? No. Because remember, that line goes through both of these points. And remember the first day we talked about if it's a solution or not? And we just said, if I had a line, if the point's out here somewhere, it's not a solution. If the point's here, then it is a solution. We're purposely drawing a line through these 2 points. So that means these 2 points have to be on the line. So we can use either one. So you get to choose. So which point would you choose? I know which one you guys are going to pick. 1, -2. The only other point that you would have picked if they're both positive versus both negative. That's the only other point that you guys would pick. Even the numbers are bigger, you're like, pick the positive numbers. I don't blame you. All right, so we're now going to go ahead and use this slope and this point. I'll show you how to use SIF to do it and how to use PSF to do it. Your choice. It doesn't really matter. But there is a certain time where you might have to use PSF to find the answer. I'll explain when and why. SIF. So SIF we already know is y equals mx plus b. So what can we fill in here with the y equals mx plus b? What do we know so far? We know the slope, so we can replace the m, right? How does the point help me? Isn't the point an x value and a y value? Equation? Yeah. So with the SIF, the only confusing part is that it's actually a two-parter. We're going to use the point and the slope to find the y-intercept and then rewrite the equation. Okay? So, ooh, that makes it hard to read, huh? Let's undo that. Let's bring this out. Let's make that papa and bring that back in. Okay. So if we're going to do this, we're going to say, okay, we're going to replace the y value with y. We're going to replace m with -4. We're going to multiply by x and plus b. And x was 1. Awesome. So everybody see where those numbers come from. Okay? Awesome. Well, let's get b by itself, because b was the only thing that's unknown there, right? So we got -2 is equal to -4 plus b. So b is going to equal to what? Say what? Because how do you get the 4 to the other side? You add 4, right? You're like, dang it, son of a gun, right? So don't forget to add 4 to the other side. Here, let me do this just so that you guys have it in your notes. So you're like, I got it. Okay? Now, slowly but surely, I'm going to get away from showing this, and here's the reason why. Not because I'm above this. It's because when it comes to college algebra, those steps will be skipped, and you're expected to know what is being done. If I happen to skip it, though, and you're like, I'm really not sure, I'm not going to sit there and go, you freaking idiot, here it is. I'm not going to do that to you. If you're not sure, I will show you exactly where it is. Okay? So please feel free to just speak up. Like I said before, you need to be your own advocate here. Okay? And I'm not going to judge you because you're trying to be an advocate for yourself. All right? So this space is exactly for that. All right? So there is SIF. So once I find b, I rewrite the equation. Y equals -4 x plus 2. Pretty easy? Not too bad? All right. So be careful with what the question is asking for, though, right? If the question is asking for the equation of a line, you're finding the equation of a line. But if it's asking for slope, don't find the equation of a line. Does that make sense? Make sure you're answering the question, right? So with the PSF, which is y minus y1 equals m times x minus x1. So same thing. I'm going to go ahead and plug everything in. So I got y minus, y is negative 2, is equal to m x minus 1. So notice that x sub 1 and the y sub 1 is actually your point. You're just plugging everything in. So really I have y plus 2 is equal to negative 4 times x minus 1. The reason why I just made that step is because this is actually a very important answer. And this is when you actually have to use this form, because this form is the only way that you're going to get the right answer if they were to ask you for point slope form. So in the directions, if I ask for point slope form, this is what it wants. Why? Remember what I said, the slope intercept form, since us mathematicians are so good at naming things, right? The slope intercept form gives us the slope and the intercept. This is called point slope form, meaning I should know what the point is and what the slope is. I know the slope, I know my points. Now notice that the points, the signs are flipped, right? This is plus 2, is negative 2. This point here is negative minus 1. The point is, the y value is actually positive 1. Everybody see that? Now, would this be different if it was the other point? Yes. But the equation of the line is going to be the same. It's just in point slope form, it would be different. So if I was to do the same thing, oh boy, let's, yes, glitching. So if I was to use this point here, okay, if I was to use this point here, then this is going to be, let's test you guys out. This is going to be y what? Is it going to be minus 22 or plus 22? It's going to be flipped. So it's going to be plus 22 equals negative 4 times x minus 6 or plus 6? Minus 6. Okay? So if we were to use this, that's what would happen. So if it was multiple choice and it wanted point slope form, chances are both of these are going to be one of the choices. Okay? So again, the signs are flipped. All right, so let's continue on with this one right here, and let's finish this off to find the equation of the line. If I was to do that, then what I would have is y plus 2. I got to distribute because order of operations. I have to actually multiply before I add or subtract. I get negative 4x plus 4. So y is equal to what? Negative 4x plus, try again. If we don't know where that came from, here it is. Okie doke. That's why it's 2 and not 6, because it's not on the same side, right? Remember that an equation is like a seesaw, right? If I want to remove this 2 here, if I take away 2 pounds, I got to take away 2 pounds on this side in order for the seesaw to stay balanced. If I take off 2 pounds on this side, it's going to go like this. That means I got to take 2 pounds back off on the other side in order for it to balance. Okay? Now, are these 2 equations the same? Yes, sir. But here's the problem. Sometimes they're going to ask for this equation in function notation. If it asks for function notation, what would this equation be? I repeated it a few times, and we have a section that says function notation. What did we do when we did function notation? Oh, come on. Let me guide you. This part right here stayed the same. What changed? That is what changed. All we're doing is replacing the y with f of x. So function notation, we're replacing the y with f of x. In function notation, we're just replacing the y with f of x. That's it. Wow, I'm skipping all over the place. Are we okay so far? Any questions on that? Okay. Now, let's look at this. The two lines are parallel. What can you tell me about parallel lines? Ooh, first time this answer is coming up. Because typically what you guys start to do is giving me definitions of parallel, right? Two lines that never touch each other. They're equidistant from each other. However, have I talked about those two things at all? I haven't. I've been talking about slope. So what is it about the slope? Yes, they're the same. Okay? So with these two lines, so let's call this 1 and this 2. So what I'm saying is that the slope of line 1 is equal to the slope of line 2, because the slopes are equal. If you look at it, they look equal. They're both positive and both pretty shallow. Okay. These two are perpendicular. What can you tell me about their slopes? So the reason I'm doing this is because this is exactly what I did when I was in high school So I'm from New York. Well, I graduated from New York. So we have the Regents exam. So that's our state exam, right? So when I was taking the math part of it, I couldn't remember what the relationship was between the two lines, right? So what I did was I had graph paper. So I drew a line, like line number 2 here, of a slope that I am determining what it is. What is the slope of this blue line? What is it? So I can figure this out, right? I can just pick 2 points. Oops, wrong color. Going from left to right, am I going up or down? Up. So it's a positive slope. How much should I rise, and how much should I run? 1/4. Can everybody agree with that? If you go from here to here, I rise 1, I went right 4. So the slope of line 2 is 1/4. Everybody okay? All right. So then what I did was I took the corner of a sheet of paper, I put it on there so I can meet a point, and then I drew that line and extended it. That gives me 90 degrees because that's what a perpendicular line is, right? So then I looked at, okay, so I drew line 1, and I said, okay, what is that slope? So let's pick 2 points there. Let's go from one point to the other. What's my slope there? What's the rise? What's the run? So going from left to right, it's going downward, so I know it's negative. So the slope of line 1 is -4/1. So then what I did was I looked at the relationship of the two and said, what's the relationship? How does the one go to the other? Anybody have any ideas? And they're flipped, meaning reciprocal, and negated. Everybody see that? One's positive, one's negative. It has to be. Oh. If I had perpendicular lines, one has to be positive, one has to be negative. Right? If you go to left to right with my arms right now, one's going downward, one's going upward. The only time it doesn't is this. Right? Any other thing, one has to be positive, one has to be negative. If one's shallow, one has to be steep. Everybody see that? Right? So I'm going to write this, but it's probably not going to make any sense to you guys. So the slope of line 1 is equal to -1 over the slope of line 2. You're like, that's confusing. It is. I'm not telling you it's not. But this is what I'm going to tell you. You just said to me, to flip and negate. Flip the fraction and negate it. Agreed. This is how I teach it. Now, are there other words for this? Yes. Some people call it the negative reciprocal. Right? The reciprocal means to flip. Negative means negate it. Same idea. I just call it flip and negate. Okay. So, let's see here. Let's say I give you so let's say I give you -3/4. what would be the perpendicular slope to that? Positive 4/3. Because I flip and negate. How about positive 4? Not negative 4. Negative 1/4. Because what's a fraction of 4? 4/1, right? So we got to make sure we're doing that. And if it's negative 2, it's going to be positive 1/2. Right? So hopefully that helps you guys understand what flip and negate really means. Are we okay here? Yeah? And yes, in this case, we wouldn't call the slope negative 4/1. We'd just call it negative 4. Right? Because negative 4/1 is not a reduced fraction. When we reduce that, it's just negative 4. All right? So, and you're going to look at this example going, okay, how does this help me? So let's say I have x plus 4y equals negative 10, and 4x plus 5y equals 4. Tell me if these two lines are parallel, perpendicular, or neither. So how would I find out if two lines are parallel, perpendicular, or neither? A light bulb just went off for you? Yep. Oh, shit. Dang it, that's recorded. Sorry, guys. Someone's going to take that bit and this destroy Chan. So, how are we going to figure that out? How do we know if two lines are parallel or perpendicular or neither? Since we've been comparing slopes, right? If we knew the slope of both lines, then we can compare those slopes and we'll know. It would tell us. Does that make sense? All right. So in order to find the slope, though, you just said, let's put it in slope-intercept form, meaning get the y by itself. Okay. So let's take a this right here and get the y by itself. All right. Tell me what that's going to come out to be. 4y equals negative x minus 10. Is that right, you said? Because in order to bring the x over to the other side, I got to subtract it, right? Then I got to divide everything by 4. Is that true? Is anybody going to freak out right now because they see negative 10 over 4? You shouldn't. If you are freaking out, here's the thing. Does the y-intercept have anything to do with parallel, perpendicular, or neither? No. Is it telling you to graph this? No. If it's telling you to graph it, yes, I would freak out. Make sense? But it's not telling me to graph it. Now, if it's telling you to graph it, chances are the graph paper that you're given is going to have points that is necessary for you to graph it. Because this is really reducing it to negative 5/2, which is really, in decimal, negative 2.5. So that means it's right between 2 and 3. Right? I'd be concerned if it was negative 10/3. Then I'd freak out. But this one I probably wouldn't freak out because I know it's exactly between 2 and 3. Okay. All right, so I know the slope here. Now, any questions on the math part here? Do I need to show anything here? Clarify anything? We're good? So we know the slope here is negative 1/4. Awesome. Okay, so now let's take a this and let's do a same. Let's get the y by itself. So we got 5y equals what? Plus 4? Yeah, graphing that one would get me kind of worried. So I know the slope here is all right. So is this parallel? No, because they're not the same, right? Can I flip and negate this to get this? No, I can't flip and negate this to get this either. So guess what this is? Neither. And there we go. Pretty simple, right? Any questions so far? Nothing? Nothing at all? Okay. What if I say to you, write an equation of a line through 5, -3, and it is going to be perpendicular to x plus 5y equals -5. Light bulb just went off again. So I'm going to tell you guys right now, if the light bulb is going off with this man right here, because I'm noticing this, you guys might want to figure out why the light bulb is going off. So, how would you guys go about doing this? Huh? Do I plug it in? So, does this line here have anything to do with the equation of the line that I'm trying to write? In what way? True. But again, read the problem. Remember I said yesterday, I'm sorry, 2 days ago, with word problems, we should read the first sentence, or at least to the first comma, write something down. Yes? True? Everybody? Yes? 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 Okay. So, the first thing it says is write an equation of a line. I should pause right there. Because what did we just say is needed to write an equation of a line? We need a slope and a point. Yes? Awesome. So, this right here reminds me right? So this line goes through 5, -3. I got a point. What's your point got to do with me? I got a point. But it's perpendicular to this line. So does this line have anything to do with the equation of the line that I'm writing? No. Because my line is going to be perpendicular to this line. It's not the same line. It's just perpendicular to it. So what am I missing? I'm missing the slope. What information is going to give me a slope? This line is going to give me a slope, isn't it? Okay? So, since I got to use the little boys' room, I need you guys to figure out what the slope of your line is going to be, and I'll be right back. Go. Did some of us figure it out? Yes? How about people at home? Did we figure it out? Oh, sorry, people at home. This means yes, this means no. Sorry. Didn't give a ledger for that one. All right, so this is the way I tell the story. So this right here, guys, has nothing to do with our line, as we were just saying. Okay? So this poor lady here wants an equation of a line. And poor lady only has a point, doesn't have a slope. So what she does is dress up all nice, goes to Mercado, and because she needs to find herself a slope. She meets this young man over here. Well, Mercado, never mind. This old man over here, this rich old man over here. She doesn't want his slope. She wants something perpendicular to it. You guys can take that joke however you guys want to, right? So she's trying to figure out what slope does he have, right? So let's figure out what his slope is. So in order to find the slope, we have to do what? Get the y by itself. Now you're seeing why she doesn't want his slope, because it's a negative slope. She wants something perpendicular to that. Fair? So his slope is negative 1/5. So what is the slope that is perpendicular to that? That is the symbol for perpendicular, and that's going to be what? Huh? 5. So now she goes, awesome, I found my slope. She leaves. This poor man, does he matter anymore? No. Bye-bye. You go away, right? So now she's coming back here. She's like, look, I have a point, I have a slope, I can write my equation on my line. Do you guys want it in SIF or PSF? You want PSF? All right. PSF it is. So now all I'm doing is just putting things in, right? I got my slope. I have my x value. I have my y value. So now I have y plus 3 equals 5 times x minus 5. So y plus 3 equals 5x minus 25. So y is equal to 5x minus 28. Is that right? Does that make sense? Okay? So again, the key things to remember here. Write an equation of a line, right? Once I saw that, I know point, slope. I need those two things. It's giving me a point. Where do I find my slope? Okay? Any questions? None? None whatsoever. Nothing at all. $28? Great question. So in order for me to get the y by itself, I got to get rid of this 3 right here, right? So in order to get rid of 3, I got to subtract it. If I subtract on this side, I got to subtract on this side. Okay? Any other questions? I want you guys to notice how mean I was to him. Like I was like talking down to him, like belittling him. Did you guys see that? Okay. Like I was almost going to punch him too. Just a mean professor, ain't I? Any other questions? Nothing at all? This was just that easy? Really? So the perpendicular line, so if it was parallel, it would have stayed at negative 1/5. But because it's perpendicular, I have to flip and negate it. So take the negative 1/5. I want you to flip the fraction. What do you get? Negative 5 over 1. Now negate that. Bingo. Okay? So anytime it says perpendicular, I got to think of flip and negate. Okay? So maybe I should put that over here. Do 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 do. So hopefully, no, so hopefully, like some of the things I explained, don't get me wrong. Some of the things I explained, I don't write down. That ought to be in the what we know. Some of them I do write down that ought to be in the what we know. So this is the reason why I record these things, is because when you're going through these problems, you guys can just fast forward to this piece and say, okay, what are some of the things that he said that I ought to write down and maybe put it into the notes so that I can, when I condense the notes, it's there, or when I make the best cheat sheet ever, it's there so I can remember, right? Because the more you write it down, the more you're going to recall, the better retention you're going to have. So my question now is, what questions do you have on the lab work?
So question 8, I didn't get it.
What didn't you get?
Because I guess it was asking for like 2 parts.
Mm-hmm.
I didn't get the second part of it.
Mm-hmm. Should I go over it?
Oh, never mind. We're talking about like the homework. So I can ask later.
Oh, you're talking about MLM.
Yeah.
Oh, I thought you were talking about lab work. Yes, you're welcome. When the light bulb went off, he goes, wait a minute, this problem looks familiar. That's why he has his paper out. So anytime that folder starts flipping, you better go, wait a minute, I better check my stuff too. No, go ahead and ask. You said MLM. So either one or two things. So if I bring up MLM, I want you guys to know that my problem might be different from your problem. But I don't have a problem going into it. So if you have the numbers, you can use your problem, or I can open up my problem and do the problem. Your call. Which section is it?
I was talking about like the homework that due tomorrow.
That's the lab work. Yep, that's what I was just doing. That's exactly what I was just doing. That is number 8. So you did understand it. That's why I was asking you if I need to do it or not. What other questions do you guys have? That was it. So everything else was easy. Awesome. Uh-huh. Yep. That is standard form. So, you know what? I'm glad you asked that question. So the question is, what the heck is standard form? Right? So let's talk about that really quick. So standard form is just that. Meaning the variable is on one side, the constant's on the other. That's all it means. Okay? So y equals -9 would be right because the variable is on one side, the number is on the other. Okay? It's throwing you off because some people won't get it and try to actually write an equation of a diagonal line and get x and y involved. Okay. Next question. So again, my goal, my want for you is that when you leave class today, your lab work is pretty much done. So if you have questions, ask. I don't have a problem answering it. Clearly, sometimes the notes actually already have your lab work done. 2 of them. I did today. You're just going to have to look and see. It might have been the last problem. Okay. So some of the things in terms of what we know, because one of the problems is saying undefined slope through this point, right? So the question is, what do I write in the what we know, right? So what should you write in the what we know if it's undefined slope going through a point? What do we know about undefined slopes? What kind of line is it when it's undefined slope? Huh? Don't go this way and say vertical. No, it is a vertical line. It is a vertical line, yes. Because you might whoop, whoop. Yes, so undefined slope means it's a vertical line, right? And you might want to in the work, because I told you guys that we don't have to remember, because it's really easy to scan with ChatGPT, and it's going to tell you it's a vertical line, it's going to be this answer, right? So you might want to say it's a vertical line and actually draw the vertical line and plot that point, and then plot a second point and then show that the x repeats. Make sense? Same thing with a horizontal line. You might want to draw the horizontal line, plot that point, and plot another point on that horizontal line and show that the y actually repeats. The x changes, but the y repeats. And it's not a bad idea for that horizontal line to say, look, as well, the slope is 0. So if I see that it's a 0 slope and it's going through a point, I know it's a horizontal line, right? The information that you write down is going to help you remember and recall, right? So what other questions do we have? Since some of you guys don't have your cameras on, and I don't get to see your beautiful face, what kind of other questions do you guys have? People at home, just unmute yourself and speak. It's okay. Nothing? So in other words, everybody's going to have the lab works done and handed in by tomorrow at 6 p.m. All right. Now here's my next question to you. I know that you've only had me for 2, almost 3 classes. Is there anything else I can do to help you learn? Nothing? Nothing at all.
One question.
Go for it.
If there's like a problem I really can't understand, like I look it up, I look through the steps, I just can't figure it out, could I email you?
You could, but this is why I prefer that you ask it in class. And there's the reason why. Because I'd rather answer that question for 30 students, that one question for 30 students, rather than answering that question 30 times to 30 individual students.
Of course. I'm just saying like a question if it like blindsides me if I didn't see it in class, something like that.
Well, is it blindsiding you because you're not there, because your camera's not on and I don't see you, so I'm not sure if you have left the room? Which that could happen, right? If you're going to the bathroom, I don't need you to bring me to the bathroom with you, right? However, so one of two things, right? If I did the problem in class, I'm probably going to tell you, go to the live lecture.
Yes, sir.
Right? So I would tell you that most likely the resources are already there. So I'd rather that you didn't use me as Google, or in this case, Changle, right, to get the immediate answer. If you looked around and you're like, no idea, then yes, you can always email me. But just don't be surprised if my reply is check the live lecture, check 3.4 notes, like that type of stuff.
Also about the camera off thing, I am in class, I am paying attention, I'm not walking away. I will send you a Canvas message about that because I have a pretty good reason to occasionally have it off.
Okay, that's certainly fine. I don't have a problem with that, because the reason is why I say it is because it's for the other students who, there are many students that will log in on Zoom and literally walk away, right? I don't want to assume that anybody's doing that because I'm such an amazing professor, but there are people that do that. And then they turn around and ask me the information that I just went over, right? So I don't want to assume anybody does that, because if this is the case, then the other person with their camera off will probably just come on, or at least send me a message to say, hey, I am here, right? But those things aren't happening. So I'm going to guess that the other person has already left the building or is snoring away in their bed right now, right? That type of stuff. So I don't have a problem with those things, but communication is important to me. So make sure that if there are information, chances are I'm going to play the compassionate card anyways, and hoping you the best with certain things anyways, okay?
Yes, sir.
Now,
If you were to ever like ask, hey Andon, quickly turn your camera on, you'd see me right there, right away, looking at the screen.
and that's exactly what you just did, right? So the other thing is that one of the things I said was, check the so-called live lecture, right? So if I go into week 2 right now, you see the live lecture here. Before you even play the video, you might want to just click on the PDF notes and say, okay, is there anything in here that would cover the question that I'm talking about, right? If it is, then go to the video and going, okay, so this is about halfway into the notes, so it's probably halfway into the video, and then go play that part. Is that fair?
Perfect. Thank you so much for that information.
Absolutely. I have zero problems answering any questions you guys have. I'm just trying to force your hand to open the lab work early so that when class ends today, when I tell you guys to have a wonderful weekend, I want you guys to already have the lab work done and you're ready to already submit it, right? Instead of going, I'm just going to open it today after class is done. Now I'm going to ask 20 questions.
Yes, sir. I totally understand that. I'll shoot you that message on Canvas soon.
No problem, dude.
Thank you again.
Absolutely. You see how mean that was to him? Okay. Any other questions that you guys might have? Yes? MLM? Okay. So my question is, did you, and chances are you probably did. So over on the left side, you see BibliU course materials. You went through that? So you clicked on that and you got, do you see your textbook here? So yours should say like MAT 1033. I don't know what section this is. This is, actually I can tell right here. Yours is 20F, right? So if you click on it, you should see an access code. You copy that code. When you're done with that, you go to Access Pearson. And then when you click on Access Pearson, then it's going to ask you to log in. So log in with your username and password, which is most likely your FSW Bucks. Now, if you never had an account there, so for the students that is first time here, you have to create an account. So click on Create an Account, use your FSW email, create a password. When you get in, it's going to ask you for an access code. Okay? Now, here's the thing. If you create the account, access code, it asks for your access code. The other option is, if you don't see it in BibliU, then what you can do is say, you know what, I'm just going to do the 14-day free trial. The 14-day free trial will give you 14 days, and then it's going to ask you for the access code again. Okay? So hopefully that will take care of whatever you need to take care of. No problem. And if you have your stuff with you, your computer with you, feel free to do it before you even leave. Any other questions? Nothing at all. So the scans for this week's lab work is going to be way better than what I've seen, what I've shown. Fingers crossed. Okay? Nobody's furnitures? Does anybody need help with scanning? Are we okay? We're good? All right. So you guys got nothing for me. All right. Well, ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. I'll see you guys next Monday. Later. Have a great weekend.